In the name of Allah. Hello guys, I am Salar Delawar Qashqai. In today's video, we are going to model large displacement analysis of this two-dimensional truss with Python and OpenSees. And also we are going to verify this example with Abaqus and SeismoStruct. You see guys, this truss has 3 nodes and 6 degrees of freedom, and also we are going to apply the incremental displacement in degree of freedom number 5, and each step we are going to output the displacement and base reactions of this degree of freedom and this degree of freedom. So the last shape of this truss is like this, based on large displacement method. And let's see the outputted result. You see guys, based on this analysis, we're going to output and show the different results such as Python code as I developed with the finite element method, OpenSees library, Abaqus and SeismoStruct. These two types of analysis, such as Abaqus and SeismoStruct, we're just going to load the outputted data and then trying to show you. For example, in here, Python, OpenSees, and also SeismoStruct has the same result, but Abaqus has different shape, but really near to this Python and OpenSees and SeismoStruct data. Abaqus large displacement analysis a little different. So let's see the Python code. This Python code performs a pushover analysis of truss subject to the lateral displacement using both custom calculations such as finite element method and Finite and OpenSees library. It models large displacement to compute the structural response and compare results with the external software like Abaqus and SeismoStruct. The key step after including parameter initialization such as geometry, materials, and simulations parameters, customized calculations, we use the Newton-Raphson method, and also trying to run it with this finite elements method to outputting the displacement and base reactions. And also we are going to develop the OpenSees modeling and outputting the parameters, and also trying to showing the displacement and base reactions of each examples, and also verified examples, and also trying to plot the data. So you see guys, in here we are going to model in first example with the definitions of the external loads in degree of freedom 5 and 6, initial displacement. We're going to define it with -1. So if you want to indicate the external forces, you can change it with your own data. These codes are available in my GitHub, and also you can download it and change it. We're going in here define the maximum displacement, degree of freedom number 5, and also coordinates of this two-dimensional truss, and also cross-section area for elements 1 and 2, and also model of elasticity. And in here we're going to define the number of steps for calculations, and also iteration and tolerance convergence, and truss length of each truss element length, and also axial rigidity for this truss element, and also we're going to initialize the data, and in first example we're going to model the Python code of large displacement analysis. So in each step we're going to apply the incremental displacement and changing the geometry of length and also angle of each element, and also calculating the element stiffness and matrix stiffness. And because this two truss has a 2 degree of freedom, so by definitions of one determined displacement, so the matrix is going to be changed by one column and one array. So this two-dimensional truss stiffness matrix going to be changed by one array and by one column. So in here we're going to apply the incremental displacement and defining Fii as a force vector, and by minusing this to the Fy by the applied load, so the F vector as a force vector is going to be calculated, and then in each step as a while we're going to use the Newton-Raphson method for these convergence concepts and solving the best displacement which is going to be converged. And so if the iterations going to be converged, so it shows the number of iterations and also increments of these steps which is go to be converged, and then outputting the angles and also residual value and also number of iterations and so many data which you want to output the data, and also internal element forces. And if the applied incremental displacement reach to the ultimate, so the analysis is going to be stopped. So, and if the iteration reached the maximum iterations, so it shows the this iteration reached to the ultimate, so you must change these values to get the better convergence. And at the end we're going to output the displacement and base reactions based on this Python finite element method. And also I developed the OpenSees code for this large displacement model. So in OpenSees model, geometry is the same as Python code, and also we're going to define a two-dimensional modeling and also copying the coordinates of the nodes, and also boundary, defining the boundary conditions and also material properties. And also I defined chord truss elements for this large displacement truss element modeling. So chord truss is very efficient for this kind of analysis when you want to define the large displacement modeling. And also for in here we're going to define the time series and for applying external forces. So in the degree of freedom number 3, and we're going to load this applying external forces, and also in here we're going to apply the displacement in degree of freedom number 5 as a node 3, and in each step we're going to output the displacement and base reactions of this truss element. I use these while functions, and if the analysis is not going to be converged, so we're going to check the different algorithm methods for this kind of analysis and to better getting the solutions and better convergence. And you see guys, I defined this text. So for example, if you use the Truss element, for example in here, beside using core truss, you use this concept of truss element, so you can active this to getting the base reaction and displacement. So it is optional, and you can see the by using truss element and activating this, you can output the base reaction and displacement of this truss element. And I used the text file outputted data for loading my data. So I defined a function to loading this text file for reading the base reactions of displacement and also base reactions of these forces. And in here also we're going to output the verified data such as Abaqus and SeismoStruct from Excel file, and also plotting all outputted data such as my Python code and also SeismoStruct code, Abaqus code, and also OpenSees code. And we run it this code. You see guys, after 0.34 seconds, this analysis is going to be stopped, and also all outputted data is going to be shown in here. So you see guys, just Abaqus a little different with this finite element methods, Python and OpenSees, and also SeismoStruct outputted data. These codes are available in my GitHub. You can download it and change it with your own data. You see guys, I just run the very simple model of this two-dimensional truss for this large displacement concept. God bless you guys. Please have a comment and tell me know about this kind of modeling. Bye.